It would be a negative over 0.
So 25 plus 5 is 30. Negative 6 times 5 is negative 30. So we get,
Sorry, 0 over
no
0.
worries, and the denominator is 0. We like this because there is hope. So now I would like to refresh our memory on the following. If I want to divide p of x by x minus 1, and I plug in 1 in the polynomial at the top and I get 0, it is guaranteed that x minus 1 is a factor of p of x. So p of 1 is 0. This implies x minus 1 is a factor of p of x. Another example. If I have a polynomial and I divide it by x plus 4, when I plug in, it has to be x minus a number. This also comes from the synthetic division. P of negative 4 is 0. Then x plus 4 is a factor of p of x. So I notice something here. My props have to be close by. Okay, I notice something here, that this is a polynomial and this is a polynomial. Careful, this is not a polynomial. They cannot think in the same way. I got 0, but this is not a polynomial. So this cannot be the same situation. But the top is a polynomial and I plugged in 5. If I plugged in 5, then x minus 5 must be a factor because I got 0. The remainder is 0. So the same thing here. So I know what I have to do. I know that both these top and bottom must have a factor of x minus 5 because that is the problem. How do I know? Notice that one other concept. When I say to you x approaches 5, I also say x minus 5 approaches 0. It's the same concept. So that's the problem. The problem is x minus 5. The problem, the culprit that creates 0 over 0 is x minus 5. If I manage somehow to get rid of it, I will find the limit. So I'm not sure why this doesn't say. Okay, so what is the other factor I need?
X minus 1.
X minus 1. I simplify because remember x does not equal 5. I'm allowed to simplify. I'm going to continue here. As you already know, I always run out of room all over the place. Now please apply the limit to what is left and tell me the number. Now we drop the limit operator because we apply it. So apply the limit to what is left and tell me what we get.
4.
Very good. Awesome. So as x approaches 5, 5 minus 1 will approach 4. So please keep this idea in mind. This is called the remainder theorem and factor theorems. And this is for a polynomial. A polynomial. If they are not polynomials, this does not fit. But if we deal with polynomials. Okay, I would like to look at an absolute value situation. Any questions on any of this? I know it's a lot. Okay. Oops, my computer is dying here. Let me plug it in. Okay, it's plugged in. Good. So let's talk about the absolute value. It's a big deal. Here it is. Can anyone refresh our memory on what does this mean? What is the formal definition of the absolute value?
Is an absolute value the distance from zero?
Yes. But what we need here is the formal definition. So anyone remembers what does this equal to? It's okay if you're wrong.
I guess all positive numbers.
So remember, x can be positive or negative, the inside here. The answer has to be positive always. But what are the options for x positive and for x negative?
Would it be positive infinity
So
or just positive?
the absolute value of x can be replaced by x, plain x, if x is positive or 0. But if x is negative, this quantity can be replaced by negative x, because if it's negative with minus in front, it will still be positive. So this is the formal definition of the absolute value. You can say, but the distance has to be always positive, and it is. If x is positive, this is positive. If x is negative, this is still positive. Why do we need this? Why can't we just forget about that, my props, and just say this is a distance from 0? Because there is a big thing, a big theory behind this. Okay, so let's talk about it. This has to be looked at like this. What am I telling you? Anything. 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 As long as all these are the same. Anything. That's the pattern. That's how we have to look at this. So now if I say, let's say the absolute value of x minus 1, not a big deal. I rushed here. That's it. All I did, I replaced this and this and this and this and this by x minus 1. This is what we have to remember. And now, for example, here's a limit from 2x plus 12 over the absolute value of x plus 6 as x approaches negative 6. What do? I have no clue. I have no clue what this is. So I don't care about this limit. I have to look at the function, analyze it, simplify it, because every absolute value has two options. Every absolute value is not a nice friendly function. It's nice but not friendly. So this has two possibilities. This has two possibilities. This has two possibilities, meaning this has two possibilities. So I don't know what this is because I haven't simplified the function. So I'm going to come back to the limit later. I have to take the function apart and present it without absolute value. Absolute value is a hindrance. It's not easy to work with at all, and we can't most of the time. So we have to simplify the function first. So we start with x plus 6. Can anyone dictate what x plus 6 equals to? Because it has to have two options.
X plus 6, negative x plus 6.
with parentheses. It's not good enough where I have to write. It's a piecewise defined function. That's how a piecewise defined function works on different pieces of x. So,
X plus 6 greater than or equal to 0.
good, which really means x greater than or equal to -6. I don't need this one.
And then the other would be
I don't,
X.
very good. For the other one, I don't care. I don't calculate anything. What is not here must be here. So if this one is greater than -6, this one, or equal to, this one has to be less than. If this one is less than or equal to -6, this has to be greater than -6. Okay, so now I'm looking at the function. 2x plus 12 over the absolute value of x plus 6 is really 2x plus 6. Remember the two key words, always. Factor, simplify. These are the key words. Okay, ready? Over the absolute value of x plus 6, which means the function has two options. Why? Because this one has two options. If x plus 6 in absolute value has two options, the entire function has two options. So what is the first option?
Sorry, why did you so the 2x plus 12, why did you change that to 2 times x plus 6? Would we add the 12 after, or? Yeah, but would
2 times
it-
x is 2x, 2 times 6 is 12.
Oh, okay, sorry.
No worries, no worries. You may see something I don't, and I'll rather go back and check. Good, so what are the two options?
So, well, one of your options would be that we have basically 2 times x plus 6 over x plus 6.
Good, which is 2. For
And then
x,
greater than or equal to -6.
careful,
And
there is a catch. Can I put -6 in here?
no,
No. Greater than -6, good. What is the other option?
it would be 2 times x plus 6 over negative x minus 6.
Good. And then that will mean -2. Because this is x plus 6, this is x plus 6 with minus in front. So then 2 over -1 would be -2 for x less than -6. Any questions so far? Is this okay?
I'm not too, like, after you like crossed out the x plus 6 is less than or equal to 0, that's where I kind of just got a little confused. What did you write beside that?
You mean here?
No, the box part at the top of the page. The box at the top right.
This one?
Yeah, what is written right there? I can't read the...
So x plus 6 is greater than or equal to 0. It's an inequality. When I solve this inequality, I have to move 6 to the other side, which gives us x greater than or equal to -6. I have to solve this. So I moved 6 to the other side to solve the inequality. So I have x greater than or equal to -6.
Okay.
I think you're talking about the circle next to it. That's the page number.
Oh, you mean this?
No, I meant the box. I couldn't tell if the greater than or equal to was something other than that.
So we follow the pattern, x plus 6, x plus 6, x plus 6, x plus 6, x plus 6. But I have to solve the inequality. So I have to move 6 to the other side and solve, because I need x. So this I really don't need. Initially I do, so to solve this. But this is what I need. And this is what I need to simplify the function. Is that better?
Yeah.
So then, when we finally got to this stage, so we replaced for x greater than negative 6, I cannot, see, x plus 6 here is not in the denominator. But here it is. So I can no longer keep negative 6 in the problem. Because this function is undefined at negative 6. This function is defined at negative 6. But this one is not defined at negative 6. So I have to exclude the equal symbol. So when the denominator is x plus 6, these two will go away, and I end up with 2. When the denominator is negative x plus 6, I will still simplify these two, but now I end up with 2 with negative 1. So that's how I get the negative 2. Do we all see this step?
Yes.
Excellent. So now finally, after all this work, I can answer this question. It's from either side. So I will determine the limit as x approaches negative 6 from the left, and you'll tell me from what, and the limit as x approaches negative 6 from the right, and you'll tell me from what. And then we will draw a conclusion about the limit as x approaches negative 6 from the function 2x plus 12 over the absolute value of x plus 6, and you'll tell me what it is. Who can tell us the first one? What do I put here?
Negative 2.
Of course. And what is the limit? We just talked about the limit law. What does this equal to?
Should negative 2?
Of course. What is the other limit? Thank you. From what?
2.
Good. And what is the limit?
2.
Excellent. Finally, what is this now?
Would it be the end?
Very good. Awesome. Great job.